What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. Can you find a possible set of whole number coordinates for the vertices of a quadrilateral that has the following side lengths? Rad 13, rad 17, rad 29, and rad 65. So of course there's going to be multiple answers to this question, but I'm going to provide you one possible answer. And again, these coordinates have to be whole numbers. So we're not talking about like square root of 2, square root of 3, anything like that. They should all have nice whole numbers. And by the way, shout out to one of my students who gave me the idea and inspiration for this puzzle. So you know who you are. Thank you very much. Hit that pause button and see if you can figure it out. When you're ready, hit play and I'll give you the explanation. So these are very interesting values, right? We're talking about side lengths. And again, if we're talking about the length of a side length, we can think about how this relates back to the distance formula, which is really a reformation of Pythagorean's theorem. So what am I saying here? What I'm saying is, if we look at all of these as hypotenuse lengths of a right triangle, this starts to make a lot more sense. So I'm going to draw out some potential triangles here that would have hypotenuse lengths of all of these radicals: rad 13, rad 17, rad 29, and rad 65. So if we look at these triangles and these different hypotenuses, we can now start to figure out what would the side lengths be for these different triangles. And that's going to be the vertical and horizontal movement from point to point. So it's going to be really helpful. Now, let's think about rad 13, because again, if I've got a and b, to get rad 13, I'm taking a squared plus b squared and taking the square root of that, which means that to get nice whole number values for the legs, I need to think about what number squared plus another number squared is going to straight up equal 13. So I'm thinking, what two perfect squares can I add together? What about 4 and 9, right? Which is 2 squared and 3 squared. Okay, so now I've got one potential triangle that's going to give me a nice distance, a nice hypotenuse of rad 13. What about 17? What two perfect squares add up to 17? That would be 16, which is 4 squared, and 1, which is, 1 squared is 1, right? 1 plus 16 is 17. What about 29? Well, how about if we do 5 squared is 25, plus, and then we also have 2, because 2 squared is 4. 4 plus 25 is 29. Last but not least, we got this one, 65. Now, there are two options here, and I'm going to arbitrarily choose one of them, but you could have 7 squared, right, plus 4 squared, so 49 plus 16 would be 65. I'm going to go another way. I'm going to say 1 and 8, right? 1 squared is 1, 8 squared is 64. That gives me 65. Now I kind of have this nice little layout of horizontal and vertical distances, and we can manipulate the triangles any way we want, but I've got potential horizontal and vertical movements that I just have to make sure wherever we start, we're going to end up back at that same beginning point to make a nice closed quadrilateral. What I'm going to do to make this easy is I'm going to start at 0, 0. So my first coordinate will be here at 0, 0. Then to get to my next point, I'm going to use these side lengths. The other thing I'm going to do is I'm going to kind of try and match them up to some extent. Like, for example, I see that I have this giant length of 8. I also see that I can come up with 8 in the following way. If I combine the 2 here, the 4 here, and the 2 here, right? All of those different side lengths, that adds up to 8. And why am I looking at those compared to the 8? Because if they're both 8, I can have 2, 4, and 2 going up on one side and 8 coming down on the other side, and they can serve as the vertical distance up, vertical distance down, or horizontal, either way, and they'll balance each other out to help us get back to that same starting position. So let me show you what I mean in real time. So let's first look at this 2, 3 triangle. So I'm going to keep the 2, 4, and 2 as vertical and the 8 as vertical. That means the 3 is going to be horizontal. So let's plot that little triangle right here. And now we come to the coordinate 3, 2. Now to get to the next coordinate, I'm going to use this triangle. And again, I'm going to go 4 vertically up and 1 horizontally to the right. So that means our next coordinate is 4, 6. Next, we're going to go to this triangle. Again, 2 is going to be my vertical distance. 5 is going to be my horizontal distance. But again, I want to get this to be a closed quadrilateral where we come back to that starting point. So I'm actually going to go 5 horizontally to the left. So there's my vertical movement, there's my horizontal movement by 5 to the left, and there's my new coordinate at -1,8. Now we got one more triangle, and there's only one option. We've got 1 horizontally and 8 vertically, and this is perfect because if I go down by 8 and 1 to the right, I end up back at my starting point, which is what we needed. So there we go, 8 vertically down and 1 to the right, and this brings us perfectly back to 0, 0. Now we have a nice polygon. It is a closed shape, 4 sides, meaning it's a quadrilateral. That's how you do it. Done. And by the way, just to reemphasize, this is the rad 13 length. This is the rad 17 length. This one is the rad 29. And of course, this is rad 65. So my solution set here for the answers, that the solution that I came up with is 0, 0, 3, 2, 4, 6, and -1,8. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining, and we'll see you in the next video. Take it easy.